Hello, I'm Guillermo Bautista, and I'm a PhD student here at JKU. And this is my lesson plan on uh, teaching mathematics through problem solving, in particular triangle inequality. And later, I'm going to explain how 3D printing is integrated. So the first part is just the lesson. So this is the lesson. At the end of the lesson, the student should be able to understand and illustrate the meaning of triangle inequality, to identify the whether a given set of lengths can form a triangle or not. Um, Third is make generalizations, and fourth is justify claims made. So the idea in this lesson is to use the 3D printed rods to let students form triangles. So here I have 3D printed rods, and they will use this to form a triangle. And of course, they will discover that um, not all triples can form a triangle, and that's what they will discover. So I want them to list the triangles that they have formed. So these are the expected answers. And the idea is to let them discover that in some cases, they cannot form a triangle. So I'm going to ask them this, and then I'm expecting two answers. A possible answer if the length of the two sides is equal to the length of the longest side. So as you can see here, we have side 1 is 2, side 2 is 3, but the third side is 5. So if you put them together, like, they will just form a line. So they will not form a triangle. The second case is if the longest side is uh, longer than the sum of the length of the two sides. So if you put A, for example, here in A prime, and B in B prime, so we will have two shorter sides here, and you have a longer side, and you have a space somewhere here. Okay. And then I'm going to ask them to give examples, uh, using more examples of these two cases. So they will have a sort of understanding of why the triangle can't be formed. After that, it's time for generalization. So given a triple means a number, what under what conditions can we form a triangle? This is triple of lengths. Maybe I should put of lengths. Under what conditions can we form a triangle? And of course, they have to discover that a triangle can be formed if the sum of the lengths of the two shorter sides is greater than the length of the longest side. And of course, after that, we need to let them represent using um, variables, and we have to expect this answer. And of course, at that stage, the students doesn't really know how to generalize yet. Like when you say, of course, in the university, we know that A plus B greater than C means that you can arbitrarily assign the values of A, B, and C. So maybe that's not yet in the level of the students. So that's why um, I asked this question. Suppose A and B and C are rearranged in any particular order. Under what conditions can we form a triangle? So they have to they are expected, or I expect them to form these inequalities here. Okay. Okay. So this is just the explanation of this one. And then for question number 8, the conditions that we've discussed above are triangles with different lengths. Can we use them for triangles with the same length? And of course, we expect them to, whose sides whose triangle have the same side lengths. We expect them, of course, to still answer yes, if they really understand the lesson. And then for number 9, uh, we now introduce what triangle inequality means, now that they know that now that they have experimented and they have understood what the triangle inequality is. Now, the part 2 of the lesson is a continuation of this lesson. So here, actually, the main purpose of this is to let them organize data and list systematically. So in mathematics, of course, we just don't teach the students the skills, like the mathematical skills. We also teach them the process skill, like the generalization, organizing data, listing systematically, and so on and so forth. So we want them to list all the possible combinations of the six lengths. And then if you can see here in question number two, given the lengths 1, 2, 3, we want to find all the triangles that can be formed using them. How do we do that? So we can list, of course, we expect them to list all the possible triples. And some students, of course, they will have a hard time listing them. Like they have to list systematically. Like, of course, they have to list. For us, it's probably easy to see that we have to list maybe in increasing or decreasing order of lengths so that we know when we have already listed a particular triple or not. But for the students, they are probably not that systematic yet. So it is our duty to, should I say our duty? Yeah, it is. We do. We have some leading questions so that they will be able to list this these triples in a systematic way. Okay, so here it looks like we have a lot of triples. Is there a way that we can verify easily if triple can be triangle or not? Of course, we still have to use the theorem that we have learned earlier, the triangle inequality theorem, and then they can check one by one. These are the triples, and they have the relationship. They have equal, they have less than, and also they have greater than. And of course, here, if they form a triangle, um, you say yes. So we want to them to create this table. And if not, maybe we can maybe write on the board or something that we have this, and they have to fill it out. Okay. So then they will know that there are actually seven triangles that can be formed from the given lengths. Okay, so this is the summary. Based on the discussion, how can we know if a triple can form a triangle? So these are the possible answers. This is also the same as above. And for this, list for the systematic listing, this is the answer here. We can arrange the sides of a triangle in increasing or maybe decreasing order, and then check if the sum of the lengths of the two shorter sides is greater than the length of the third side. Okay, so that's basically the lesson. So where is 3D printing? I'm a teacher trainer in the Philippines, and what I plan to do is I demonstrate this to the teacher, and then introduce them how to create this. So this is very basic, and I think this is the if you're going to teach a 3D printing class, this could be the first activity. So just the teachers maybe just use GeoGebra or maybe Tinkercad to create these strips, and then they just it's better if it's GeoGebra so they can learn a little bit about the 3D view, and then they can learn about using the extrude tool of GeoGebra, and then they can learn how to import it to Tinkercad. You know, these strips has a number actually. So you can see here number 5, number 4. So maybe they can do it in GeoGebra and then put it in Tinkercad and then put the numbers. So very basic skills, and then they 3D print it. So I'm really excited actually to try this out. Um, so from the point of view of the teacher, they will learn the 3D printing when they already experience this. So we have this system in the Philippines where we like there is this called demonstration lesson or sometimes peer teaching where the teachers pretend that they are students and they perform the activity and like act as like students. How would the students answer? And of course, this can be also tested for actual students. That's it. Thank you very much. I hope you enjoy my lesson.